Hi, thank you for joining me on Notes over Perimeter Word Problems. I wanted to go over some quick vocabulary with you. First, I wanted to talk about the word perimeter. Perimeter means that you're going to add up all the sides. Now, most of the time we're going to be talking about a rectangle or a square or a triangle. So I wanted to kind of talk through the perimeter of a rectangle or a square really quickly. When you add up all the sides, here's our square rectangle. You have a length and a width. If I added all those up, length plus width, then you have a length down here, and then you have another width right here. See how I have two L's? So I have two L's, and I have two W's. I have two W's. So we could use the formula 2 times the quantity L plus W, L being the length and W being the width. If you like to just see it as L plus W plus L plus W, you're welcome to do that in these notes. Another vocabulary word I wanted to talk through with you is isosceles triangle. An isosceles triangle is a triangle that has two congruent sides. Congruent just means it has the same length. So if we looked at the triangle that's given to you, AB right here is going to be the same length as side AC. Those sides are congruent. They're going to be exactly the same length. And this is what a basketball court looks like, i.e., it's going to be a rectangle when we refer to a basketball court. Our directions say, draw a picture to represent the word problem below, then write and solve an equation for each problem. In these following examples, I'm going to help you set up the equation, and then I'm going to quickly solve it and show you how to answer the question. But I'm not going to spend a lot of time explaining solving to you. So here we go. Example 1. The length of a rectangle is 7 more than twice the width. The perimeter of the rectangle is 224 inches. Find the dimensions of the rectangle. So first thing I want to do is I want to draw a picture of this shape, and I'm going to draw a rectangle. I'm going to label the top part the length and the side the width. The first sentence says, the length of the rectangle is 7 more than twice the width. That means I'm referring to this side right here, the length. Because it also uses the word than, I'm going to use this back part first when I'm starting to set up my equation. So I'm going to go to the length, and I'm going to put twice the width first, so 2W. Then I'm going to come to the front part of this, which says 7 more, and more being add. So I'm going to add 7 to that length. So the length of this rectangle is 2W plus 7, and the width is just going to be W. It also tells me that the perimeter of this is 224 inches. So when I set up my equation, I'm going to use the formula P equals 2 times length plus width. And I'm going to substitute in all the parts that it gives me. I do have a perimeter, which is 224, and I do have a length, which is 2W plus 7. This is a good equation, but if I want to go ahead and clean it up just a little bit, I'll go ahead and do that. In other words, I want to look at this right side of the equation, and I want to see if I can simplify that by order of operations. So for me, let me go ahead and write 224 down. Inside of my parentheses, because that's the P in PEMDAS, I see that I have 2W and W, so that's going to make that be 3W, and then plus 7. That 7 cannot combine with the 3 because they are unlike terms. This is a really great equation too that we could write down inside of that box, which is acceptable. Or you can actually continue to simplify, meaning I need to distribute this 2 inside the parentheses. So I'd have 224 equals 6W, and then 2 times 7 would be 14. This again would be a really great equation for this problem. So now I'm going to take that equation, 224 equals 6W plus 14, and I'm going to quickly solve. I'm not going to walk through my steps with how to solve. If you need more help solving, then please watch some other videos. So 210 divided by 6, that's going to be 35. We find out that 35 is our width. The question isn't asking what the width is. The question is asking us to find the dimensions of that rectangle. So I do know that the width is 35, but now I need to know the length. So I'm going to substitute in a 35 for that width up here, and I'm going to go ahead and find that dimension. 2 times 35 is 70, and then 70 plus 7 is 77. The length of this rectangle is 77, and the width is 35. That's my answer. Let's look at our next example. Each of the two sides of an isosceles triangle is 8 centimeters longer than the third side. The perimeter is 55. Find the measures of each side. So I'm going to go ahead and draw a picture of this isosceles triangle. An isosceles triangle means that you have two sides that are the same length. So I put these little hash marks to represent those are the two sides I want to be the same length, even though my triangle doesn't look like that. I'm also going to just point out this is going to be side 1 for me, this is going to be side 2 for me, and this is going to be side 3. Let me reread this. Each of the two sides of an isosceles triangle, that means side 1 and side 2, are going to be 8 centimeters longer than the third side. Well, right here is my third side, and I don't know how long it is, so I'm going to use x as my unknown to represent that length of the third side. I do know the other two sides, though. It says the other two sides of that triangle are 8 centimeters longer than the third. Well, this word than means that whenever I start to write my equation, let's go to this first side. I'll put the third side first, which is x, and then I'm going to do 8 centimeters longer than that. So I'm going to add 8 to that. Because this first side is the same length as the second side, I can actually put x plus 8 as my other side. Whenever we talk about perimeter, remember it's the sum of all sides. So we're going to add up all the sides. So I'm going to take side 1, x plus 8, and add it to side 2, which is x plus 8, and add that to the third side, which is x. And they did give me the perimeter of this, which is 55. This is a great equation, but I want to clean it up. So I'm going to say 55 equals, combine like terms. All these x's are like terms. So x plus x plus x is 3x. And this 8 and this 8 are like terms, not because they're 8s, but because they're constants. 8 plus 8 is 16. This is a great equation and possibly even better than the one above. I'm going to go ahead and solve now. If you need help solving again, refer to some solving videos. And we find out that x equals 13. Now, the question doesn't say find x, it says find the measure of each side. In fact, this x is my third side, so I do know one of my sides, but I need to find the other two sides. So if x is 13, then I'm going to go ahead and plug that in or substitute it in for this x. And I'm going to have 13 plus 8 here, and I'm also going to have 13 plus 8 on this side. Side 1, 13 plus 8 is going to be 21. Side 2, 13 plus 8 is 21, and side 3 is 13. The dimensions of my triangle are 13, 21, 21. Let's look at our next example. If one side of a square is increased by 16 centimeters and an adjacent side is decreased by 6 centimeters, a rectangle is formed, whose perimeter is 100. Find the length of the square. I'm going to go ahead and draw my square. And if you know this, the square's side lengths are all the same. So I'm going to say the top side is x and the sides are also going to be a length of x. With my square, I'm going to increase one of the sides. So that means I'm going to make it longer by 16. In other words, I'm going to add 16 to that length, and that's going to be my new side. The other side, or the adjacent side, the adjacent side means the side next to it. So the side next to x plus 16 is now going to be decreased by 6. So we're going to take this side on the left and we're going to decrease it or take away 6 from its length to make now a shorter side. It's going to be just this long. So if I were to finish out what this new shape looks like, you can see that the new shape is now a rectangle. If I were to kind of draw this out off to the side, it would look something like this. My top would be x plus 16, and my side would be x minus 6. Now let's write an equation to help me find out the value for x so that I can eventually find the length of the side of the square. So my equation, again, because it's a rectangle, we're going to use 2 times length plus width. Well, let's substitute stuff in that I know. I know the perimeter of this is going to be 100, says it right there. The length of this, I'll say, is going to be x plus 16. And the width of this is going to be x minus 6. That's a really great equation if you want to say that's how I would write my equation, or you can clean it up. On the right side of the equation, I need to simplify by doing order of operations. Parentheses come first. So I'm going to have 2 times x plus x is 2x, and 16 minus 6, that's going to be a 10. Now I'm going to go ahead and simplify still the right side of the equation. So 100 equals 2 times 2x is going to be 4x, and 2 times 10, that's going to be 20. This right here is a really great equation for trying to find the value for x, which is the side of the square. I'm going to go ahead and quickly solve this. So just sit back, relax, and enjoy the show. So when I solved, I found out that x equals 20. So what does x really mean? Well, if you remember back, I'm going to go ahead and erase some things. We said originally that a square had the same length sides, and we named them x. So when I solved for x right here, we actually did find the side of a triangle, which that's what the question is asking me to do. So x equals 20 is my answer. Last question. The perimeter of a basketball court is 144 feet, and its length is 50 feet more than its width. Find the dimensions of the court. I'm going to go ahead and draw my basketball court, and I'm going to label the length and the width. I also know the perimeter is 144. So let's go ahead and read. It says the length is, so I know that we're talking about this side right here, and it says 50 feet more than the width. Because of the word than there, I'm going to go ahead and write the width first, and then I'm going to write 50 feet more than that. So I'm going to add 50 to that. And I'm going to go ahead and set up my equation. Because this is a rectangle, we're going to use 2 times the length plus the width. And I'm going to go ahead and substitute in all the information I know. The perimeter is 144. The length is going to be W plus 50. And the width is still just W. I'm going to use order of operations to clean up the right side of this equation. So 144 equals 2 times. My like terms are W and W, so that would be 2W plus 50. That's a really great equation if you wanted to write that in the blank. Or you could also write 144 and distribute in that 2 and get 4W plus 100. I'm going to go ahead and quickly solve this so we can find out what the width is. I'm finding that the width is 11. But the question isn't asking me just to find the width, it's asking me to find the dimensions of the court. I do know what the width is, so let's go ahead and find the length. The length is this top part, and I'm going to go ahead and say 11 plus 50, which is 61. Therefore, the length is 61. The dimensions of the basketball court are 61 by 11.